Hello, data science students. I hope you're all doing well, staying happy, healthy, and safe. So, the live stream is starting up. Did a similar test to what I did last time, and yeah, there's still about a 40-ish second delay, around 41, 42. It's a little upwards of 40 seconds between when I say a thing and you hear it. So, yeah, let's get started. Let me see. Right now we have what, like seven people on the stream. Ooh, wow! I'm getting audio from my own feed in my ears. Let me take care of that. Oh, hey, John. No, you can't be a student. John is an old friend of mine. Get the hell out of here, John. No, you can stick around. Let's see. Let me see. Cameron, is this waiting for everyone else as well? Yeah, Cameron. This is visible for everybody right now. Let's see. So let's see what we got here. Uh, so it went from 7 to 3. I don't know if we had disconnects or there were random people logged in who didn't know what they were in for. Let's see. So out of those of you who are here, which is probably John, who you should have no questions. Uh, you pay good. You don't pay good money for anything. Yeah, it's not 1995 anymore, John. Um, so Cameron, it's probably you, John, and somebody else. So right now, if you guys have questions about Challenge 5, go ahead and spit them out. Let's see. While we're waiting, I got 6, 7, 8, 9 requests to do the live feed today, so hopefully more of you will start showing up in a second. Let's see. Okay, we got Tanner and Grant. Cool, I was expecting to see both of you guys. Let me actually make a list here so I make sure I... Hey, Scotty boy. So we got Tanner, we got Grant, we got Drew, and we got Cameron. Okay, so first of all, how's my frame rate? Am I coming in smooth to you guys? And again, I got to wait 40 seconds before you guys even register that I said that. So it's looking good on this end, and aside from not streaming at an optimal resolution, YouTube thinks the stream is moving along pretty well. Okay, so if you have specific questions about the challenge, go ahead and post that, and we will address some of those. So hopefully, since the assignment's due today, you guys have already downloaded your data set. I've got a copy here, so when you download it, you'll get something challenge data underscore challenge 5.zip. And if we unzip that, you're going to get a data file that is your spirit animal name. I am my own spirit animal. drjones.csv. And the contents are going to look something like this. Okay, so 3 columns, just a standard CSV file. The first column being timestamps, second column being radio frequencies that you're listening to, and third column being signal amplitudes for that timestamp. And so going back to sort of the premise of this, you have 5 radio frequencies. So in that second column, you have 5 unique values. What you're trying to do is identify which 2 of these 5 are not random. Now keep in mind, sometimes the best way to find out which something is not something else is to find out what other things are something else. So depending on how you want to go about separating out your frequencies, it might be easier for you to find the random frequencies first and then consider everything else to be a non-random frequency. While there's other ways you can go about it. You can do a statistical analysis. Not going to tell you which one. That's your job. I've got a lot of emails from folks asking me which statistical method that they should use to figure out the difference between the random frequencies and the structured frequencies. And the answer is your job. You can do it. Trust me. The list of statistical methods that we hinted at in our linear regression lecture was pretty small. So if you go through each of those systematically, you'll figure out which one works for your data. Okay, cool. We have comments now. Okay, let's see. So yeah, smooth as butter. That's what I want to hear. We're coming across good. So the streaming is good, which is really great considering my sort of wonky Wi-Fi setup. At some point, I really need to run Ethernet in this house. Right now, I'm using a Wi-Fi repeater to get signal up here in the office. So I'm kind of glad that it's running smooth because it's a couple hops to get where we're going. And usually I like to be hardwired for these kind of things. Okay. Let's see. And for those of you who weren't here to begin with, Jay McCraw, old friend of mine, who has decided to antagonize me on this this live stream. That's okay. You're not antagonizing me, dude. At some point, the camera started slipping down. There we go. And how do you recommend we plot the linear regression? Oh, okay. Well, that's actually a pretty straightforward question. I like straightforward questions. So plot it as a line plot. The thing that you need to keep in mind is that the linear regression is different than your polynomial regression in that to have a smooth polynomial regression, you need lots of points that you're doing your prediction across. For the linear regression, you only need, it's a line. You just need 2 points. So if you get keep in mind the y value is going to be your signal intensity, and your x values are going to be your timestamps. So you'll need to plot your first point from the x value that is your lowest timestamp for the frequency that you're regressing, and the other end is the other end of that line is going to be the x value for the farthest out, the largest timestamp for the frequency that you're trying to plot. I got a couple questions by email about how to figure out what those XY pairs are. So if you look back at the linear regression lecture, you'll see the math there. But just for kicks and grins, let's see. Let's just make a test file here. I just call it. Let's give it a more meaningful name than that. linexample.py. So remember your slope-intercept formula looks something like this. Y equals mx plus b. And so once you've got your, let's add some more comments here. So m is your slope and b is your intercept. And so now you might not know it yet, but if you think about it, you already have the starting and ending x values that you're going to want to plug into this formula. So let's say, and I'm going to make up a list of timestamps here. We'll just call it TS. And let's just say that it had timestamps of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 55, 72, and 1926. Because why not, Okay. So let's pretend that these were the timestamps that you found for one of those frequencies. What you want to do is you're going to want to find the minimum timestamp. So you can use NumPy, so NP has something in it called np.min, and get the minimum timestamp out for that particular frequency. Now, granted, I'm not giving you all the code to do this because you guys gotta work for it too. So, and also get a maximum timestamp similarly. So, numpy.max or np.max, depending on how you aliased it. Okay, and so this will get you your min and max timestamps for that particular frequency that you're wanting to regress and plot. Okay, so now remember we said the timestamps are your x-axis, so those are your x values for your regression, which means you have to find one other thing, and that's the y value. So if you have two xy points, boom, you got a line that you can plot. So let's see here. So using, I think you guys can see my pointer. Using y equals mx plus b up here at the top, we can predict what the y value should be, since you've done your linear regression parameters. I'm making that assumption already because that's not quite copy paste from the slides, but it's really, really close to copy and paste from the slides. So you guys can translate that English from the slides into Python. I'm pretty sure. Okay, so we're assuming that we've already figured out our slope. Let's just pretend it's a slope of like 2.3 and an intercept of, say, 1.7. These are meaningless numbers just so we can plug something into our code for an example. Okay, so the y value that's going to be associated with that minimum TS timestamp is going to be your slope times your minimum timestamp, okay? Plus your intercept. So not terribly complicated, and also not terribly surprising. Similarly, you just plug those values right back in for your max timestamp, and boom, you've got a y value associated with that max timestamp x value. And that xy pair are the things you're going to want to plot. So then, just like we typically do matplotlib, you do just a line plot, and you're going to want a list of x values and a list of y values to plot across. So I see a question pop up. Let me finish this train of thought, and then I'll have a look at it. I'm getting the quarantine hair. It's all down in my face. Okay. Where was I? Oh yeah. So remember, your plot function is going to want a list of the x values and a list of their associated y values. So they have to be in the same order in both of those lists. So since you just have two, it's really easy to just plug these guys in as your minimum timestamp and your maximum timestamp as your two x values. And then your y list being your min timestamp y value and your max timestamp y value. So there's a lot of details left out here because, one, you got to do it for your assignment. But the basic structure of how to plug those values in and get the xy pairs for your linear regression, that's it. You just have to figure out your regression parameters, so that slope and intercept for each of your frequencies. Let's see. So let's go over here, and Cameron asked a question: linear regression parameters, as in just funneling out the good frequencies from the bad? No. So you have to find. So let's say we're calling the non-random frequencies the good ones. You want to do a linear regression using the methods from the linear regression lecture on the non-random frequencies. So let me pull up our assignment document. I can kind of visualize it for you. Let's see. Teaching Data Science, Spring 2020. Assignment folder, challenge 5. Okay. Okay, here we go. Okay, Windows 10 is weird because it keeps wanting to resize my window as I slide it across my desktops. I think it's because they're at different resolutions and it's trying to keep things looking the same. Okay, so we've got plots of our 5 different frequencies here. You can see pretty quickly by looking at this that the red set of dots is one of the structured frequencies, and the purple set of dots is another one of the structured frequencies. Once you identify which value in column 2, so your second column, is a structured frequency, you want to separate that out and then do the statistics on just those values for your linear regression. And similarly for the second one, you want to do the same thing. Now, that shouldn't be too mind-blowing. So I don't think you're going to struggle too much with that in the long run once you figure out which frequency is which. That's the tricky part, okay? This is where I've probably got the most questions. How does my program figure out without me telling it which ones are random and which ones aren't? The shortest possible answer to that is you need to figure that out. But I will give you some hints here. Really, the biggest stumbling stone that people seem to be having is sorting their data out, and that's that can be challenging on occasion. So let me save this, and let's do something else. Let's do a different example. So one of the ways that I've recommended for people to do this is utilizing a dictionary. So let's make something. We'll call it dexample.py. Again, I'm not going to give you like the way to do it. I'm gonna work this through an example. Let's say that let's come up with a good example here. Okay, while I'm thinking of good examples, let me read the comments we got here so far. Okay. Okay. So Morgan, I like your question. Hold on to that thought. I think we might naturally flow into that after this one. Okay. And John, I'm glad to see you, John McCraw. Glad to see you, and yeah, get back to work, dude. Stay safe. Anyway, and Tanner, do the structured frequencies have to be those colors? No. Matter of fact, I would just let Matplotlib use whatever color it automatically assigns to them when you do your plots. It'll make life easier. Ideally, I would like to see the let me pull up the document. One thing I would like to see is the polynomial. Notice in this example, the polynomial regression is a blue line and the linear regression is a red line. That's actually pretty trivial for you to do. So I'd like to see those colors, but honestly, at this point in the semester, with all the craziness we got going on, if you can just get your plots working at all, and you can distinguish one color from another, I'm going to be happy with that. And for some reason, my camera keeps it's just not maintaining tension. There we go. So I'm not too worried about the color. I'll email the TA and let him know, not to be too picky about the color. Okay, so where do we leave off? Dictionaries. Okay, so first bit of advice, go back and look at the dictionary examples from early in the semester. So those were some of our first set of slides where we talked about like easy bake solutions for handling data structures. Yeah, look at those. That's going to be your best resource. But let's say we are keeping track of fruit at a grocery store. Okay. And let's say we wanted to make a dictionary called fruits. And we have, actually no. I'm going to start off in something more similar to what you're working with. let's start off with a list. So we're keeping track of apples and oranges, because why not? Okay, so we'll call this our raw data. And our list of raw data looks is a list that looks something like this. We have the type of fruit, and we've got how many, these numbers are not going to make sense for real fruit, how many grams they weigh. Let's say it was a 50-gram apple. How many grams is that? How big of an apple? I don't know. Just roll with me. Suspension of disbelief. Okay, so let's say we had another that was 45. Another one that was super tiny, like an obscenely small apple, 15 grams. And let's say we had an orange of 20 grams. Let's just make life easy here. Now let's make this look kind of like your data. Your data is kind of spaced out. There's stuff mixed in with other things. A huge apple, several huge apples, and a tiny apple. Okay. Okay, so let's say that this is what your raw data looks like. A list of fruit types and how much they weigh. Okay? But what you're interested in is getting, say, the average weight for an apple or an orange in your set of produce. So how would we want to do that? What would be, this is Python. There's like 1,000 different ways to do everything in Python. But what is one potential way to do this? Let me move me over here so I'll be out of the way. Okay, so one potential way to do that is to use a dictionary. So for a dictionary, how we'd want to do this is we'd want to loop through each line in our raw data. Okay, and let's just print the line. So remember our mantra from early in the semester: code compile, code compile, code compile. Never write the whole thing. Write a little bit, compile it, run it. You know, for Python, there's not really a compile step, but code compile is a good mantra for pretty much any language. For Python, I guess you'd say code interpret. Okay, so let's just run this example. Okay, and boom, yeah, this little for loop here just loops through each line of our or each row of our list, and outputs that to the screen. So we know that at least that part's working. We're able to go through our data. Now, what you would want to do, though, if you wanted to keep a dictionary where the type of thing, like the type of fruit or the type of frequency, by type of frequency I mean the frequency. I'm not hiding this from you very well, okay? So let's say we wanted to keep track of weights for each of these fruits in a dictionary. You know, we could keep a list of all of the weights associated with a fruit, with the fruit as the key. So our fruit type is the first element in each of these lines. So using the fruit type as your key, you could then append the fruit weight. I guess technically we're talking mass when we're talking in grams, but, you know, nomenclature and such. Okay, so this should give us, and I'm grinning at you because Well, you'll see. I'm grinning at you because this is obviously going to work, right? Okay, so let's save this and run our code. Oh my gosh! Everything broke! Why'd it break? Well, let's look at our error. It says there's a key error for apple. Well, what does that mean? Well, it means there's no entry in the dictionary right now for apples. And I'm showing you this for a very specific reason. It's a common error that I see people get. So the first thing that you're going to want to do is the first time you encounter any fruit, or frequency in your case, in your list, it's not going to have an entry in the dictionary, so you're going to have to create that. A quick, hacky way to do that would be just to try to append your fruit weight to a list at fruits at key fruit type. And if that fails, we can assume that there hasn't been an entry made for that yet. And what we can do is then make a list at that index. And again, there's more straightforward ways to do this, but this is the simplest way. You can then initialize an empty list at that key and then append the value. The more concise way would be just to go ahead and put your fruit weight in, and that way you wouldn't actually have to do this line at all. But I found that for some people, especially if you're new to Python or programming in general, it sometimes makes more sense to create the empty list first and then add something to it. I don't actually care which method you use. Just use the one that makes the most sense to you. Okay. Let's see. Okay, so now let's print our fruits dictionary and see what happens. So we coded a little bit. Now we're going to compile again. Okay, cool. So for a really small dictionary, you can print the whole dictionary and make a little bit of sense out of it, because we see that we've got a key for apples, followed by a list of numbers after, and then a key for oranges and another list of numbers. Doing this for your frequencies in your actual data, there's so many of them that if you just print the raw dictionary, you're not going to be able to make heads or tails of it. Okay, so just bear that in mind. But if you wanted to, say, check out your dictionary, what you could do is loop through the key value pairs. Remember, the key is like your index, if you want to think of it that way, for your dictionary. In this case, our key is apple and orange, but in the case of your data, your key will be, some numeric frequency. So we can loop through key value pairs in our dictionary.items. And we could print something out like key is key. And then on a new line we can print our vowels and just make it look nice. Add a line in between. Beautiful. A happy little line. It'll be our secret. Yeah. Bob Ross of Python, not really. Okay. So, yeah. I bet you guys thought you'd be free from Dr. Jones's dorky humor if we did this online. Guess again, buddy. Anyway, so you can kind of get a better look at what the contents and sort of structure of your dictionary is if you print it out kind of like that. But do what works for you. That's the important part. Okay, but the cool thing is we can use this same sort of structure to go ahead and do statistics on just the list of data associated with each of these keys. Sounds interesting. Sounds like something you might be able to exploit for your project. You'd be right. Okay, so instead of printing the vowels, let's actually just let's take that line out altogether, and let's calculate an average weight. So we can do numpy.mean and just pass it our list of values. Now, one of the things that, if you're really, really paying attention to me writing code right now, and I hope you are, and I know some of you would say this in class, before I'd even have a chance to reconcile it, you didn't include numpy at the top. Darn right we didn't. So we got to do that. So import numpy as np. Now we can go back down to the bottom, and this should work now. And so now we can print our average weight for that fruit. Let's run our code again. And boom, we've done a statistic on a list for a particular set of things that we extracted from a somewhat unstructured list that we read in. That was our raw value, our raw values, our raw data. That's probably as far into that example as I want to go, because I think if I take too many steps further, I'm going to give you a little too much for your assignment. Yeah, it should be pretty good. Let's see. Will this video remain on YouTube after you're done with live? This is great, and I would really like to reference it while I do my project. Yeah, of course. Yeah, I'm going to keep this up. The last live stream I probably will take down. Not this one, but the one before this, I probably will take down before next semester, because I think I gave a little too many details in that one, and you know, you don't want to give the magic away. I don't want to make it too easy for you guys. Like I said, you got to do some work for it. But yeah, I think that. Let me see. What was Morgan's original question? Okay. Morgan's question that I said we'd follow up after we did this example was, I'm also having trouble plotting the polynomial regression. I get multiple lines across. Okay. I see what you're saying. I get multiple lines across the points. Yeah. Okay. So if you're getting multiple lines across the points, what's probably happening is you're probably doing a line plot between your raw data. You don't want to do that. So if it looks like a crazy zigzag, you know, if we keep doing this online, I need like a multi-camera setup or something, man. I just put a big. Did you know you could buy adhesive whiteboards? Yeah, they're terrible, but they're convenient. I've got one in my office at work that's just like the worst thing ever, mostly because it got incredibly scratched up. But got an 11-foot roll of that stuff, really cheap online. I put a whiteboard up here, so this would be a time where like drawing something would be really convenient. I guess technically I could make my tablet over here do it, but we're doing this on the fly, so we'll roll with what we've got. Anyway. So if you're getting a zigzag and it's touching all of your points, chances are you're doing a line plot between your raw data points, which you don't want to do, but that's okay. What you really want to do is do your, let's see, let me pull up something here so I make sure I'm giving this to you in the context that it was presented. Yeah, okay, this is it. So if you look at our slide here, your NumPy polyfit. When you do your polyfit, you plug in your raw x values and your raw y values, and then the degree of the polynomial model. Spoiler alert: the degree of the polynomial model that's going to work best for your data is not going to be high. It'll be a fairly low number. Matter of fact, if you go too high, you probably get some really weird looking results. Now, when you do your polyval to figure out what xy values to plot, this is where you're going to plot it's where you're going to get the information for plotting your regression line. So params is going to be the parameters that's returned by polyfit. So don't bother manipulating those in any way. Just plug them directly in as the first parameter in polyval. The thing that you're going to have to do is give it a list of x values that you want to do the regression for. I think all of your data goes from a timestamp of like 0 to 100 or something like that. I can't really remember 100% what the parameters in my script to generate those were, but we can have a look. Let's look at my data file real quick. Okay. Hey folks, let me show you something really cool. There is a command line stats package called pipestat, and not the word pipe, the symbol pipe, pipestat. And if you love working at a console, it is amazing. So, but it works with white space delimited data files as opposed to comma delimited. So let's make it a duplicate of this, and we're gonna see something cool. I say that, and now I'm doubting whether I installed all of the tools that I want to show you real quick. Call it drjones.tsv for tab separated values. Let's replace our commas with tabs. And now if we look at our TSV file, we got our tab separated values. Stat, and let me get my big head out of the way in the video. Oops, wrong thing to grab. You can use a program called collex for column extract. Let's look at that first column. Okay, so that'll give you just the first column from your data file. Let's get this up a little higher. And let's pipe that through max. 99, okay. And pipe that through min. 0, yep. I have a high degree of confidence that your timestamps all span from 0 to 99. And that makes sense because if it's a sample window, you know, it's the first timestamp of your sample window is 0, and the last one is going to be whatever the extent of your sample window is. So I believe you all had 100 millisecond sample windows. Okay. So in that case, I accidentally made this part easier than I wanted to for you. So what you could do then is you could actually do your regression for a list of x values from 0 to 99. So you could use like the range function. Let's and like so use range and do 0 to 99, and if we print that, we'll see what we get out. Sometimes I feel like Python is sarcastic. Yeah, between Python 2 and Python 3, they made range a type unto itself, and I like to treat it like a list. There we go. Okay, see, magic. Actually, so it'll give you 99 elements, so up until 99. So I want to do that to 100. Yeah, okay. And see, that gives you a list of 0 to 99. So you could use the range function to generate a list of x values going from 1 or 0 until 99 and do your regression over that. So that would be a way to get your finer resolution x values. Now keep in mind, polyval is going to, let me pull the window back over there. Polyval is going to return a list of y values. So it predicts y values for the list of x values that you provided to polyval. And then you can just do mplot.plot your x vals and then your y vals, and then that should give you your smooth line. But yeah, if you're getting zigzags between your raw data points, chances are you're actually plotting over your raw data, and you don't want to plot over your raw data. you want to plot over your regressed data. So the list of x values that you want to regress over, and then the list of y values generated by polyval. Okay, so we have more questions. Okay, since the key would be considered a tuple in our case, to be able to. No, the key doesn't need to be a tuple. The key is just going to be a single float. So your values are going to be a timestamp and a signal intensity at that timestamp. But yeah, your key itself will be just the frequency. Okay. Oh, and then yeah, you said never mind. I think you figured that out after you posted, and that's okay. Okay, so okay, cool. That makes sense. Thanks, Dr. Jones. You're welcome. Yeah, I'll give you 40 seconds to ask more questions because that's the delay length. And we're getting pretty close to the 5 o'clock hour. Not that we have a hard limit or anything, but you know, working at home has like a whole different set of rules. You know, I mean, you've got to trade time because especially if both parents are working, you got to trade time taking care of the kid and then doing house stuff and then doing office stuff. So it's a juggling act. Yeah, this COVID thing is really introduced a lot of interesting environmental changes for people who can work from home, and it's fascinating. It's actually not bad. It's just different, kind of fun sometimes not, but you know, nothing ever is fun all the time. Let's see. I feel like 40-ish seconds is probably passed by now. We'll give you like 10 more seconds. 10, 9, 8. I'm not going to do a countdown. I'm not going to bore you that much. You know, I think that pretty much covers most of the questions that I've gotten by email, and I think I hit all the things you guys asked for in the chat. Last time I did this, the chat didn't appear with the live stream retroactively immediately. It was like several hours at most, or at least rather, later before the chat transcription showed up in sync with the actual video play. So chicken or steak depends on the occasion, depends on what we've already been eating. We've been eating a heck of a lot of chicken lately, so we broke it up last night and actually made some pork chops. Yeah, I don't know what we're having tonight. I think we've eaten our leftovers, so we're probably gonna have to cook something for real tonight. Yeah, let's see. And Cameron, do we have plans for a final? Okay, so our plans for the final haven't changed. They're the same as before, in that I hate giving final exams. So your last project will be your final. The final project was posted last night. It's neural networks. We posted our first intro lecture on neural networks yesterday morning. So yeah, it's a pretty interesting project. This project, your final project, is different than your other projects in that previously what I've been doing is I've been giving you data, and then you've been giving me code to process that data. This is sort of turned on its head. I'm going to give you the majority of not all of it, but I'm going to give you the majority of the code to actually do your neural network. You have to come up with a way to train it, which means you have to generate the data for training it. So this is flipped on its head. Now, the neural network code, I've got a nice library that's going to do most of that for you, and then you have to generate your data. And I leave it up to you to figure out how to generate your data. If you are ambitious and a confident coder, you can write a program to generate your data for you. If you're more of a hands-on and maybe someone who's not a super seasoned programmer, but you're good at like writing things out or working with spreadsheets, you can generate your data that way. It has to follow the format. The training data has to follow the format that's specified in the assignment document. But yeah, this is actually a really exciting project. You if you read through it, I've specified like a certain threshold. Like your neural network has to be correct with its guesses X% of the time in order for you to get like a D or a C or a B or whatever. Um, yeah, it's based on how smart your neural network becomes. And you can submit as many times as you want. There's a leaderboard. You just upload your neural network to your trained neural network up to the website, and you can opt in to being in the leaderboard. You don't have to post your scores. But it's really cool because a lot of people start competing with each other to see how smart they can get their neural networks at the end of the semester. It's like my Super Bowl, like the geekiest Super Bowl you can have. Uh, but yeah, it's a pretty fun project. There are bonus points involved. I think it's if you're in the top three, you get some bonus points. But you're only eligible for the bonus points if you post to the leaderboard. So you're not required to post to the leaderboard. Let's see. So yeah, that was the plan for our final. Oh, oh. So the proper question was, would I prefer a nicely grilled chicken or a nicely grilled steak? Usually a nicely grilled steak. I like a good steak. Um, yeah, one of the best steaks I've had on the planet happens to be not super local, but like North Mississippi local. Uh, Old Hickory, and I hope they're still open. It's been a long time since I've been there. Old Hickory in Columbus is just that's I've been eating that steak since I was like a small child. Like if my dad ever had to go to North Mississippi for a business trip and I could tag along, we'd end up going there. So it was like a once a year sort of special thing. Yeah, that's some good stuff. Um, Also, my wife makes a really really mean balsamic steak. Like yeah, it's really good. Okay, so Grant has a question. So timestamps would serve as B0 and B1. Uh, B0 and B1. Are you talking about B as in our? If you're talking about B as in our intercept, they wouldn't serve as that. You would calculate B0 and B1 uh, from your raw data. You would use it as the minimum the minimum timestamp you would use as your x0, so your first x, and the maximum timestamp as your x1, so the two different endpoints of the line that you're going to plot, if that makes sense. And that should, I think that was fairly clear. Um, if you still have questions, though, yeah, you guys can shoot me an email or anything. Um, Yeah, I haven't tried a whole lot of steakhouses in Oxford. I've had steaks at places, but not at places that are like just like steakhouse. There's apparently one on Six outside of Oxford that I hear is pretty good. I was actually hoping to go there before before lockdown. Hopefully, after lockdown, we'll have that opportunity. Yeah, we'll see. The thing that I'm missing most though is pad thai. Oh my gosh, I am missing some pad thai for sure. Okay, so we're almost at 5 o'clock. Let's say I give you 40 seconds, and we can do a open question and answer session. So let's just wait until it ticks over to 4:50, and then I'll start counting. Sort of like in class, you don't have to ask questions, but if you got any like random stuff you want to ask, you got 40 seconds to type it in there, and I'll start answering. Once I start answering, I'm cutting it off. So, because we're running out of time. My wife actually had a toy related accident today. Our little girl was playing in the kitchen and left a bag on the floor, and she kind of slipped on it, and we were worried she broke her ankle, but it actually looks like it's just a nasty sprain. So I want to get down and help her out as quick as I can. Yeah, so we've got, okay, for me, we're hitting the 40-second mark. Yeah, let's see. Okay, someone asked, Cameron asked, just an FYI, whenever you Alt-Tab to a new window, the stream gets really laggy. Yeah, that doesn't surprise me. There's a couple reasons that could be happening. Um, One, in order to stream video this high res this quickly, I'm willing to place a bet. I'm using OBS, by the way. I'm willing to place a bet that OBS is probably using GPU accelerated encoding to do that. And when you Alt Tab in Windows, it wants to do these nice, pretty visual effects to make it look all smooth and futuristic. Man, I miss like Alt Tab in Windows 95. It was just like a bar with icons in it. You didn't have to use a lot of processing power to like make that usable. But now they got to make everything pretty, so it probably increases the load on the GPU to do those transition effects when you do it, so it lags the video, would be my guess. The other possibility is that is a large and abrupt change in the video stream, and it makes it harder for it to encode. So it does compression. And the more random movements, not just movements, but movements and visuals are in the video stream, the harder it is for it to efficiently compress them, which could hypothetically cause the stream to lag out. Those are just two guesses. Is it? I don't know. Okay, so yeah, I guess Cameron, I guess you were the only question there. So sad, so sad. I miss the end of class discussion with you guys. It's always a lot of fun. That's one of the downsides of doing this remote or online. Lack a little bit of that interaction. But I've had some good conversations with you guys on Skype, so that's been cool too. All right then, folks. I'm wrapping it up. If you have any questions or anything, shoot me an email, and good luck. Oh, I actually do have one more thing to say, and it's incredibly important. Super, stupid, important. Are you still watching? You better still be watching. The crazy, stupid, important thing is next week is dead week. So I can't change the due date for this assignment to help you guys out because it's dead week. However, I will maintain a due date of today for the assignment, but I will not start deducting points for late submissions until Monday. Well, close of business on Monday. So at 11:55 p.m. on Monday, I'll start deducting late points. But it's not due on Monday, it's due today. Okay? I'm just giving you a generous grace period. And so, yeah, that. Oh, hey, someone said they went to Aloha. I'm so happy to hear that. Like, we haven't gone out in, like, forever. And we really like the family that runs Aloha. They're just the best folks in the world. So, yeah, if you want Hawaiian barbecue and the best drunken noodle in town, they have the best drunken noodle I've ever had. Yeah, my favorite pad thai is Pic Thai, but my favorite drunken noodle is Aloha. So, yeah, yeah, check those guys out. That's a great place to end this, thinking about good food. Anyway, I'm gonna run downstairs and check on mommy and the baby, and hopefully your ankle's feeling a little bit better, and hopefully you guys have the answers you need. Like I said, if you need anything, shoot me an email. Otherwise, I'll see you in cyberspace.